This is a review of Assignment 9. So here's my class hierarchy diagram, and we'll just start at the top with snack. I'm going to double click on that. It'll take me to the code. As you can see, it is an abstract class. It has a couple of read-only fields for price and name. So these will be settable, as you see in the constructor here. And their values will be available after an object of this class is created. However, you cannot change those values once the object is created. And then I've got an override for string, so we can write out snack food values. And in fact, override that in later methods as well. So back to the hierarchy, we have junk food. And junk food derives from snack and has a constructor that takes an additional parameter, this third one, and as its base, in other words, in this case, the base for junk food is snack. As the base constructor, we simply pass along name and price, and then we set calories from fat, as you see. And we've added a public read-only field for calories from fat. And further refined the toString method to write out information about junk food. Health food does a very similar thing. The biggest difference is that it has a different parameter. It's fresh until instead of calories from fat, and there's a corresponding public read-only field. So here we see an example of one of the terminal nodes, candy bar, that derives from junk food. Now it has a constructor that takes two parameters, the same that snack does, the name and the price. Its base class, however, takes three parameters, and that's the calories from food third parameter there that you see. So in other words, we are determining in junk food that there will be a number associated with calories from fat, but we don't actually specify that as part of the candy bar constructor. Now this may or may not be what you want to do with your classes. I'm really just showing you that it's possible to have different constructors for your base classes and derived classes and actually hard code those values into the derived class constructors as you see here. Potato chip is very similar, as is apple, but the difference here is rather than doing a hard code, we're actually calling a method. So you can actually do processing at runtime to determine the values of your parameters. And similarly with banana. So here we see an updated version of the hierarchy, and you'll note that snack implements iClonable. You can see that here. And then all the terminal nodes implement iClonable. Now, interestingly, because junk food and health food are both abstract classes, they don't actually need to implement iClonable, which would have just been an abstract method anyway. It is important that snack implements iClonable so we get the proper polymorphic behavior from our objects in the terminal nodes, candy bar, potato chips, apple, and banana. Snack simply states that it implements iClonable, and we have added an abstract method that returns an object called clone. That's all we have to do. For one of the terminal nodes, we also want to state that we implement iClonable, and now we have to actually implement the clone method. So it is an override, of course, and all we have to do is create a new candy bar, and a reference to that candy bar is returned as an object from our method. And then in food locker, so now stock is just a matter of calling store.add on chooseRandomSnack, where chooseRandomSnack is generating a random number from 0 through count, which of course it's always one less than count, so it doesn't go over the size of the array. And then I use that random number as an index into my snack catalog, which is to say one copy of all of the snacks that I have, and I call clone and use the as keyword to change the object reference, which is returned by the clone method, into a snack reference. The snack catalog itself is a static list that is initialized by a static constructor, and as you see, we get a copy of each of the possible snacks. So all of that code is inside of a library, and if we go back to Vend, we see we have a reference to that library in our vending machine. And if we look at the design view, we see that now there is a third tab page with our list box for snacks, our text output window, and a stock machines button. So the event procedure for stock machine is going to call the stock method of a food locker, clear all the items in the previous list, and then add those in. And every time the selected index is changed, we will change the text of the text box snack message control to be the toString method of whatever snack is selected. And because this is polymorphic, the appropriate toString method will be called. So it looks like this. And with Snickers, we get a different message than with Lay's, than with Chiquita, and that's polymorphic behavior. And that's the review of Assignment 9.